I'm joined by some wonderful members of our student community, as well as our tech ed instructor, the wonderful Mr. Tom Johnson. And they're going to talk a little bit tonight about our amazing STEM program and some of the offerings that we have. So I want to give you a chance to really be able to hear from them about some of these opportunities, and also to kind of experience live what they actually do to bring to life some of our amazing opportunities here in our STEM environment. So without further ado, I'd love to hand it over to our tech ed instructor, Mr. Tom Johnson.
Hi there. Thank you. Yeah, hi. I'm Mr. Johnson, and I teach a number of our tech ed classes here. And I guess I'll start out with our tech ed philosophy. I'm gonna go ahead and read this for a moment, and then just talk about it. So students learn how to use new technologies to approach open-ended problems, prototype their designs, analyze feedback, redesign, and retest their ideas. With an emphasis on project-based learning, students apply their knowledge, develop collaborative skills, and demonstrate creative solutions to their problems. All of that's a kind of a long way of saying that we learn by doing. The students in the projects that we teach, they will design something and they will build something and they will test it. And more likely than not, the first time it's not going to work. And they will refine it and incorporate improvements, and it'll work better. And the further refinement, and just through iterating, learning by doing, hands-on, these students are creating some really impressive projects. Next slide, please. All right, so some of the opportunities that we have here. Our digital media class. This is a class on sort of learning to compose and present digital media, and like Photoshop and Adobe Illustrator and that type product. For programming, we start out with an introduction to programming class. It's a very gentle introduction to Java, no experience required or expected, and that progresses into programming 2 and some other options. 3D modeling and printing. That I'm gonna show you. Oh, I skipped my favorite, engineering. And I'd say it's my favorite because that's my background. I was a mechanical engineer for 20 years. That is, we cover a variety of different engineering disciplines and a number of projects in that class. 3D modeling and printing. It is learning to use some CAD software, computer-aided design, as well as taking our projects and these virtual designs and printing them, creating a real product. That's something that just still amazes me, that you can go from the virtual to the real in so little time now. Robotics. We have a lot of robotics classes and teams here at the school. I'll talk a fair bit about that here in a minute. Computer science. After our programming 1 and 2 class, we AP computer science. And our app development, that is writing applications for the iPad and iPhone. And then finally, our technical computing and data analysis class. That's a class that's designed for our students who are headed off into technical majors, math, science, engineering in college. And that is a sort of programming heavy class where we teach MATLAB and do some data analysis. Next slide, please. All right, so here's a student who's, an interview with a student who is currently in engineering class, and they were assigned to design in 3D software a clock. And I'm going to stop talking and just let the video play.
All right. So, so Tahira, this looks really, really cool. I've never seen anything like this. I got to be honest. So, can you talk to us a little bit about how you actually went about creating this clock in your engineering class, and what was the process, and just kind of walking us through some of those details? I think would be really neat for us to see.
Uh, Um, so first, in order to like make a clock, you need to start with like a basic foundation of simple gears to move in the right ratio. And like behind this component that I just switched off and on, you can basically see the gears right here. There's 4 gears. These two are a 20 teeth and a 64 teeth. And then the ones on the bottom are 16 and 60 teeth. And then the ratios will move in a 4-to-1 ratio and a 3-to-1 ratio. And then you multiply that ratio, you get a 12-to-1 ratio. And that's like the basic ratio you need for a clock to function. So the hands move in the right ratio. And then from that component right there that keep turning on and off, I created this circle and extruded it on the component so we can make a face of the clock. And you can see how this component is attached to the face of the clock. And then from this big component, I created like smaller circles around it to make 12 around for each hour, as you can see. And then from there, you can see, since we don't have a motor, it won't look like the hands are moving in the right, like the exact ratio, but you can get close enough so it moves like in the right ratio. So this gray hand is a minute hand and this red one is an hour hand. And you see how the gray hand is like in the middle of 3 and 4. And so if I move the hour hand to the 1 basically, because that would be 1 hour from 12 to 1, you will basically see this gray hand create a full revolution back to this area. And I can try to move it.
Oh, that is cool.
Yeah.
Yeah.
And then you can see it keep hitting that marker between 3 and 4 as you go around. And if you have a motor, it will be like more like, I want to say, precise in how the ratio moves.
So,
Okay, so yeah, that was a student project. Tahira's done a fantastic job with this clock. It's one thing that's kind of hard to tell there. There's the gears in the background. There are some templates that you can use to create gears, and those templates were entirely too plain. Tahira created those gears by hand, each and every one of them. That's something else. Okay, next slide, please. Okay, so course overview. Just for our incoming freshmen, we have Introduction to Programming and 3D Printing and Modeling and our Robotics 1 class. Next, thank you. Okay, and then for 10th grade, we have the same programming, 3D printing, Robotics 1, but some more options open up. Our computer science and our intro to engineering, app development. Okay, advance please. Okay, and then again, 11th grade, more options open. Especially our Robotics 3-4-5 class and AP Computer Science. And then finally in 12th grade, it is it's the same classes that are available. Okay, all right, let's talk about our robotics team. our robotics team is really, really solid. They have done just a phenomenal job these past few years. Requirements for the team are interest. That's it. I don't expect any prior experience or knowledge. All I ask for prospective members is that they are interested in joining the team and are willing to work. This is different from our robotics classes. This is an after-school sport. It spans 2 seasons, fall and winter. It's daily after-school practices. It's a pretty intensive commitment. We compete in something called First Tech Challenge. We're one of about 6,000 teams worldwide. The team has done very, very well. Past 2 years, they've qualified for the World Championship. I'll brag about them a little bit. At one point last year, they had the 6th highest score in the world. You'll get a chance here in a minute to meet some of the team members. And then it brings in skills from all over, all of our different tech classes, 3D printing, the programming, all of this comes together to help put these robots together. And now in a second, I'm going to show you a video. You can see the screen over on the right. 6010, that's the robot to watch. What you're about to see is all pre-programmed. It is all autonomous. They had to coordinate with their partner, the other robot that you'll see, and using computer vision, they had to find the blocks with stickers on it and grab them and move them under sort of the limbo bar. And they had to coordinate this in such a way that they didn't have any collisions or anything else. So if you could play the video. Saw there. It's probably hard to appreciate what they just did, but that was just an outstanding performance. They did incredibly well with that. It's hard for me to say enough good things about how well they did last year. Okay, next slide, please. Okay, so that's sort of it with the reading of the PowerPoint, and now we're actually going to step into the STEAM lab, and I'll show you show you around a little bit. So I'll be right back.
So while Mr. Johnson is getting ready to come out here, folks, I have to say I was so excited to actually have you see everything that I forgot to introduce myself. Just so excited, right? But you probably don't recognize me because I have my mask on. So if you haven't met me before, I'm John Kunz. I'm the director of upper school admission, and I cannot be more thrilled to have you all here with us tonight, as I said earlier. So we are going to follow Mr. Johnson around right now.
Okay, so if you can just kind of stand around, this is our STEAM lab, and it's where a lot of our tech classes happen. The facilities that we have here are just outstanding. I'm going to highlight a few. Laser cutter right here, where we can cut different materials with the laser. And over here, we have a number of our 3D printers. You can see this one right here is currently printing some parts. It's making something called cable chain for another bit of our equipment. This is a CNC routing machine. We can use that to create robot parts, or let me quickly grab this, engrave signs and make things kind of like so. And I'm not sure if I'm on camera.
There we go.
Okay. Moving back, you can see some of our robotics materials that we can build from. And then I'm not going to step back there, but if you look way in the back of the room, we have machine tools. We have a lathe and a mill and drill presses. We can fabricate parts here. The facilities that we have here, I mean, I can't emphasize enough just how excellent the resources are in the STEAM lab. With that said, I'm going to turn it over to to three of our students. These are our robotics team captains, and they're going to talk a little bit about last year's robot, as well as the robot that they are currently working on. So with that said, I'm going to step off frame and turn it over to Adrian, Samir, and Debay.
Yeah, so hi, I'm Adrian. I'm a senior. This is my 3rd year doing robotics.
I'm Samir. I'm also a senior, and this is my 4th year doing robotics.
Hi, my name's Abay. This is my 2nd year doing robotics, and I'm a sophomore.
Yeah, so we're members of the upper school robotics team, and first we're going to sort of walk you through how we designed last year's robot. We have this sort of cool poster here. So our robot last year was called the Cobra, and all these diagrams were made with like computer-aided design, which I think you saw a little bit earlier today.
So basically, as you can see, we have the different components of our robot, the intake system and our lift. And basically to achieve these products, we went through a lot of different prototyping and designs to get these intake systems. And like for the lift here, we had an earlier design of like a linear slide, which worked pretty well, but we found a more efficient lift, which we ended up using on our robot. And then they will talk about the system.
All right, so I'll talk about this right here. This is our intake system. So I'll explain the game last year a little bit later, but basically we pick up these cubes, so they kind of are these like bricks. So we kind of take them in through here. So I helped with this. This is called I call it the slapper. And yeah, we just went through many iterations. Like I remember my first prototype, it was like this big. It was super chunky, but then after like 3 iterations, it came down to this slim thing that you see right here.
Yeah, and so all of the sort of different iterations are documented in our engineering notebook here. And so you can flip through and see sort of some of the different pictures. And so not only are we sort of learning how to create designs, but also sort of keep track of them and explain them through words. So this is what I did last year. It involved a little bit of some statistics I was learning at the time. And so also as you flip through, you can see there's entries on many different topics. So this one's a code entry, and then this one's about the lift. And that sort of speaks to how you don't only have to like building and designing to be a member of our robotics team. You can also be interested in like programming or like industrial design, art, as well as sort of outreach events or service and promoting our team's like social media. And then this is also like a 3D printed part we made. So that's something you're interested in. There's a place for you on the robotics team as well. Yeah, so now we are going to head back and see all of these designs in person and actually see last year's robot. So when we come back here to our field, you can see our robot, the Cobra. And yeah, so they're going to talk a little bit about the game.
Yeah, sure. So last year's game, we were supposed to pick up these stones. So it kind of reminds me of a Lego brick. And then we lift them up, and then we kind of place them on this little grid, which is called the foundation. So yeah, the objective of the game was to kind of get the highest stack. Like the higher the stack, the more the points. And that's kind of the general format of most of these first tech challenge games.
Yeah, and so you can see sort of from the floor that we were looking at, just sort of the design and practice. So like a base slapper helps sort of intake the block that we can then use to make a really tall oh, sorry, not tag, stack. And yeah, so I just sort of move around. Looks pretty nicely, I guess. And yeah, there's some interesting drive features that we did through like programming. So if you can see, there's like some lights on the side, and that indicates sort of which side of the robot is the front. We use these cool wheels where you can move side to side as well as forward and back. So technically, each side of the robot could be the front. So if you press a different button, the lights will light up and it'll sort of change. That sort of helps with navigation. There's typically like 4 robots going around during a match, so that sort of helps avoid collisions a little bit. Yeah, and so Samir's driving a robot over there. He's using a gamepad controller, which is kind of like an Xbox controller, which is kind of cool. And the phone, it's connected to a phone, which is connected through Wi-Fi to another phone that's on the robot, and that's sort of how it moves around. Yeah, Samir, do you want to talk more about like the design, I guess?
So as you can see, we have the intake system, what they did with the slapper to help secure the stones. And then when I head over to the foundation to stack, and we use the lift that we built to lift the stone up off the ground and place it onto the stack of like bricks. And then part of the game was to be able to move the foundation with the tower on it. So we had little bars that came down here, and we're able to basically move the whole foundation with our tower on it, staying intact, and then let go, move back, and leave it where we need to place it. So that was one of the cool parts of the robot last year.
In this sort of like tall, like tower-like position, I guess, is sort of why we call our robot the Cobra, because it looks kind of snake-like, it's like the thing, see, with the green wheels. And as you see it extended, you can also see like that yellow cord that sort of goes around, and that's encasing all of our wiring. So if you're interested in like sensors, like wire management, or stuff like soldering and anything electrical, you can also join the Robotics Team. There's definitely a place for you. So yeah, that was last year's robot. And then so for this year, we are very excited to have so many new members on that. We actually had so many people that we couldn't be on one FTC team because there were just way too many of us for the limits. So we ended up breaking into 2 teams. And sort of how it worked out was based on like COVID and who was staying more remote and who was coming in person. We were able to divide the team between like remote and in person. And it turned out that like remote had more returning members, whereas in person had more rookie members. And so they, sort of the captain of our in-person team, will now show you some of the stuff he's working on for this year's game.
Yeah. So the objective of this year's game is to kind of take these ring-like objects and kind of get them into the robot, and then kind of shoot them out into those like goals over there to score points. So let me demonstrate a prototype. This is supposed to take in the ring and kind of like shoot it into our robot. So let me turn it on here. So it kind of goes like this. And it kind of goes up there. Do the second one and stuff like that. This is our like first iteration, so it's kind of wobbly. But next, and then so once we intake the little rings, then we need to shoot them out. So give me a second. It takes a little time to wire this up. So then we had another team working on this whole outtake system. So it's supposed to shoot these ring objects, and as soon as I get it working, so we kind of just feed it in and it shoots them. It's so fun to operate this. I love doing this. It just kind of shoots them out like that. So yeah, that's a little overview of this year's game and what we've been working with since we got the challenge in about September. So yeah.
All right, I think we'll take it back over here to Mr. Johnson and also, I believe, our slides. So if we can pop up the slides again.
Okay, and I'm going to go step back in my office and see if there's any questions, and we'll go from there.
Great.
Okay. Oh. Right. Getting ahead of myself there. Our STEM certification program. So we've got a program for students who complete a lot of courses in a lot of our engineering courses and our math and our science classes. We have a certificate program. And next slide, please. Okay, all right, there we go. Q&A. So does anyone have any questions? Anything that I can answer, or maybe have the students take a stab at?
Like defining moment at SSSAS or like in STEM.
Hey, Mr. Johnson,
Yes.
we have a question here that we're going to ask Miss Adrienne Lai. So hopefully you can see Adrienne here. So the question is for Adrienne, let's see here. What is her most defining moment in STEM?
Yeah, so I think my most defining moment in STEM has sort of been being a member of the robotics team. I've sort of been able to learn a lot and grow a lot. I wasn't the most confident person coming to high school, but through robotics, I sort of was able to build confidence by becoming sort of more knowledgeable and sort of building more skills. And especially I'm the programmer on my team. And so being able to have a lot of success with that has boosted my confidence a lot and sort of makes me really interested in going into engineering in the future.
Excellent. All right. And we do have a couple of questions that have come up into the chat here. So let's see here. I know that we had one here, Q&A. Okay, so one question for you all is, how many hours per week does a robotics team practice, and where are the competitions?
I can start by answering. I guess so. After school for robotics, we meet sort of now in this virtual setting from 3:15 to 5 every day. Sort of last year it was 3:30 to 5. So it is after school during the sports period or like extracurricular period. But no need to worry about sports credits because by participating in robotics, you earn 2 credits because you sort of participate in the fall and spring seasons. And then do you guys want to talk about competitions?
So how the first, we participate in first tech challenge. So what there is there's qualifiers. Then if you advance through that, you go to states. And then if you advance through that, you get to worlds, which is what we got to last year. So at the competition, we just play this game and if you get to a high ranking, then you can kind of choose your who you work with, like who the other team is with you, and it's more than just robotics. It's more like of a community. Honestly, I get to know some of the people from the other teams at the competitions. Like I know a team from Maryland that we worked with last year, and it's a really fun environment where we all come together around STEM and stuff.
Yeah, and they're sort of located throughout Virginia. So we compete against teams in the DMV area, so DC, Maryland, and Virginia. So it's sort of a fun way to make friends with students in the DMV who are also really interested in STEM robotics, as I was saying.
Okay. And can any of you expand on the STEM certificate program? Do you have some knowledge about that?
Yeah, so I'm actually working on completing my STEM certificate program right now. So sort of what it is there's a variety of different sort of qualifications that you can meet to sort of have this designation on your diploma. So sort of one of them is grade requirements. I believe it's not nothing below a B+, I believe, in a STEM course. That might vary based on AP and sort of honors and regular classes. Then there's also so then also you should have leadership experience in STEM. So you can sort of earn that through the robotics team or sort of all those different things. There's also a component that's experiential or hands-on learning. or summer learning. So you can complete that by attending the Virginia Governor's School for STEM, as well as participating in sort of a summer STEM course. So like for me, I really am interested in aerospace. I think it's really cool. So I've participated in like Virginia Space Grant Consortium programs over the summer. And so that sort of helped me meet that qualification. And then the final two that I'm working on is I need to sort of present about one of these experiences. So this past summer, I did a research experience with a Davidson professor that used computer science to determine the best metric to accurately measure commitment to inclusivity in tech companies. So I need to make sort of a bulletin board presentation for that. And then the final thing is I need to complete my senior project in STEM. And so a brief overview of the requirements. It sounds like a lot, but it is really manageable. I personally really love STEM, so it wasn't a hassle at all. And so yeah.
Is anyone in robotics also involved in athletics?
Yeah, so during the fall and winter seasons, yeah, I'm here doing robotics. But then during the spring season, I do tennis. So yeah, I'm a sophomore. Last year I made varsity tennis, kind of got cut short due to these circumstances. But yeah, so I was a part of that. I played tennis. Robotics season, if we like qualify for worlds and like advance higher, it kind of a little bit goes into the next season, but it's very manageable and you're not required, but a lot of kids stay in extra, come in on like after their spring sports and during lunch and stuff. Like they're really dedicated folks to work on the robot. And yeah, so.
How would you say the robotics courses integrate math and science courses into the program, or are they completely separate?
So yeah, like for robotics courses, there's definitely more math like than science, where you can do calculations or in like programming. Yeah, and also there's like physics with like understanding in the courses. It depends on like what sort of projects you pursue in those robotics courses. So like in robotics 3, 4, and 5, you pursue a project of your choice and you work towards that. So like right now, what we're doing is that we're doing like a module design where we're going to have separate modules on the wall, which basically you can put a marble through them and does like cool things inside those modules. Yeah. Good. Right.
Yeah, and something to add on to that is like with Robotics Team, I started as a sophomore, and so there's a programming feature called like a proportional integral derivative turn sequence where you have to like know what an integral is and like a derivative, like that's sort of how it works. And as a sophomore, I was doing algebra 2 trig, so I had never taken any calculus, but Mr. Johnson still like explained to me. He didn't really use like integral or like calculus terms, so I didn't know if they were yet. But it was sort of cool to have like a preview of like what was it to come. And like I just learned what an integral was like a few weeks ago in my math class, and I was like, oh, now it makes sense. Like now I know the real terms to describe it. So there is some overlap between the math and science courses and robotics.
Another question is kind of regarding like work with tech companies. Do you ever work with some tech companies to learn more about kind of some of the programming and maybe some of the robots that they have? Or have you had like some summer internships where you've experienced anything along those lines?
Yeah, so with robotics, there is an opportunity to sort of reach out to companies and sort of gain that experience. As a team, we sort of haven't gotten to that point yet. We haven't really tried that yet. But I will say, if you're interested in internships or working with tech companies, it is possible. Last summer, actually, before COVID happened, the director or the head of the math department, Mr. Weiss, actually emailed like a bunch of us to apply to SEAF, which is a science and engineering apprenticeship program, if we're interested in having an internship. And I actually received one from the Naval Research Laboratory. Unfortunately, that was cut short because of COVID, and I was like too young to do it virtually. But I was still able to like meet with my mentor and sort of have that experience working with a professional in the tech industry. So if that's something you're interested in, like there's resources here to sort of help you find those opportunities.
What about like managing schoolwork and the robotics program? Like how are you able to manage that? Is there a balance for you?
Yeah, I think well, at least for me, I've still been able to do my homework and stuff. Like the teachers here are very like accommodating. So say if we'll have like a robotics competition, and like we're working like till like say 6 o'clock for the previous like few days, trying to get it ready for the competition. Like teachers will be accommodating for that stuff. Like they'll give you an extension if you need one and that kind of stuff. So I personally, I've never like had to get one, but I know teachers are willing to do that. And plus, like Mr. Johnson and like the robotics team, like they'll understand if like you have homework. Like you just got to tell them that like, you know, if you can't get your work done, I think that's more of a priority over the robotics team. Right. But yeah, they're very accommodating.
And what language do you use to program your robot?
So for our for the robot on the robotics team, we use onbot Java, which uses like Java programming, which Adrian specializes for the team. And if you want to talk about like how you use Java on like a robot.
Yeah, so for the robotics team, we code in Java. And so we use this platform called like Android Studio, where you can sort of code and sort of first has its own like package of code and sort of objects and functions that you can use that like match with the robotics parts. And so we sort of use Java in that sense. We code for 2 different sort of periods in the match. There's the tell it off, which is the driver operated period. So all those controls Samir was using on the gamepad to move the robot around, that's one element I code for. And then the other part is the autonomous program. In a match, this would happen right at the beginning before there's any drivers. And it's the robot moving with only pre-program instructions. So, you know, you have to use sort of sensors as well as cameras and TensorFlow, which is like a imaging software to get some data to figure out how to move around. And that's pretty tricky. I would say, like, I spent a lot of time on that. Like, you have to do a lot of functions to make sure it's consistent and like accurate. And another thing is like, there's 4 robots on a field at a time. So there's 4 robots moving around. So you don't want to hit anyone. So that's just kind of fun. But if you sort of don't know Java, that shouldn't stop you from being interested in programming for robotics. There is a block programming. So like if you're familiar with Scratch, there's basically that for robotics. So you can still program if you don't know Java yet.
And this question is probably for more Samir and Adrian, since you're seniors now, but like in terms of how like your robotics classes or any of the STEM classes that you're taking, like have those factored into some of the colleges that you're looking at and the choices you have, and even maybe the application process?
Absolutely. So like going into high school, I wasn't totally sure what I wanted to major in, but I was interested in technology and I joined the robotics team and absolutely fell in love with robotics. And for college, I'm hoping to study for computer engineering and work in some robotics programs in college. So that robotics is definitely like giving me like this sort of passion that I hope to pursue later on. So
great. Adrian, any more?
Yeah. Like similar to Samir, I didn't know what I wanted to study going in. Still don't know completely, but at least I know like computer science, engineering, that's something I'm interested in. And then sort of with how you mentioned sort of like the classes or the teams sort of working into a part of the college process is so some colleges ask you if you'd like to submit like a portfolio of work to sort of show what you've done. And sort of I've created one for the programming stuff I've done, both in classes and on the robotics team. So that is sort of a way it can be worked into your application.
So would you say like the work that you all do, I mean, would you say that robotics is a hobby, or is it something that you legitimately want to maybe pursue, you know, beyond high school?
It's definitely something that I personally do want to pursue. And then like First Tech Challenge is known to many colleges, and I've talked to them and they've gotten like really excited when I tell them I'm on their first team. And it's definitely something that I want to work with, especially with like the engineering side, but also with the computer science side. It's like why I want to do computer engineering. But yeah, and they have a lot of colleges have a lot of robotics programs and stuff that I've found I'm really excited about.
Excellent. Well, that's about the time that we have for the Q&A. What we're going to do now is if we can pull the slide deck back up, that would be great. Perfect. Okay, now that we've had our Q&A, and just keep in mind, if you have further questions regarding the STEM program, obviously our students are more than happy to engage you in some of your questions, and Mr. Johnson as well can definitely, he's always willing to answer your questions. He's always down here in the STEAM lab. If you happen to come to campus on a tour and he is here, he will immediately come out to greet you and answer any questions that you have. Next